All right, section 1.5 deals with postulates and theorems relating points, lines, and planes. Now, some of this can seem quite intimidating when you just look at the words here, but a lot of these are very simple. The first one, postulate 5, says a line contains at least 2 points, and a plane contains at least 3 non-collinear points. What that means is you have to be able to identify 2 points for a line, because once we have 2 points, look, going right through those, we got a line. So anytime you have a line, you know that there are at least 2 points that can most definitely be identified, even though we know a line contains an infinite number of points. And a plane contains at least 3 non-collinear points, because if you take a line with 2 points, once you add a third point that's not in that same line, you can identify a flat surface now. Only one unique flat surface will go through those 3 points. And that kind of ties to postulate 7. So anytime we have a plane, we know that there are going to be at least 3 identifiable points on there, which we can use for some proofs later. Postulate 6 says through any 2 points, there's exactly one line. So anytime I have 2 points, they have to be collinear, because I can draw a line through those 2 points. Okay, it looks something like this. All right, now I know that's a segment, but I can add arrows to the ends if I want to. And all of a sudden, we've got ourselves a line. Through any 3 non-collinear points, just like we were saying in the first one here, if these 2 don't make a line, I can draw only one plane through them. The reason it has to be non-collinear is because if the 3 points are in a line, there are many planes that can go through here. All right, any plane that can go through that line. So it has to be non-collinear points to define a plane. Postulate 8 says if 2 points are in a plane, then the line that contains those points that are in that plane. So if I were to draw a plane, which I'll use this parallelogram style to identify this limited plane here, if I label any 2 points within that plane, I know that this line right here, every point in that line is in that plane, which makes perfect sense. If I draw 2 points on a piece of paper, the line connecting those 2 points is also on that piece of paper. That line's not going to jump out of the paper and go vertically or anything like that. It can't. Postulate 9 says if 2 planes intersect, their intersection is a line. This is a little trickier to draw with one of these things, but I can give it a try. A good example of 2 planes intersecting, if you were to look at the intersection of your ceiling and a wall, it's a line there at the top corner. So when 2 planes intersect, you have a line. If 2 lines intersect, they intersect at exactly 1 point. I don't know if this really requires any explaining, but you know, they share exactly 1 point. They're not going to share 2 points. That's really the big thing. It has to be exactly 1 point. 2 lines can't share more than 1 point unless they're the same line. Theorem 1.2 says through a point, or through a line and a point not in that line, there's exactly 1 plane. So if I draw a line like this, and I label, now if we looked back, we said a line contains at least 2 points. So by starting saying through a line, I know I have at least 2 points with that line. And it says, and a point not in that line. Well, then how many points do we know we have now? 3. And we said that any 3 points, there's 1 plane. So the conclusion is if we have a line with 2 points, with at least 2 points, and a point not on the line, we have exactly 1 plane. So a line and a point give us 3 points to make a plane. Theorem 1.3 says if 2 lines intersect, then exactly 1 plane contains the lines. So I'm going to draw 2 lines. And this is the reason these are theorems, because we use the previous statements to make these conclusions. Theorem 1.3 says if 2 lines intersect, 1 plane contains those lines. The reason for this is we know that the intersection, we said the intersection of 2 lines is 1 point right here in Theorem 1.1. So we know that there's a point right there. Okay. We also know that a line contains at least 2 points. So for every line, we can label 2 points. Well, we've already got one point labeled right here. That one's on this line and it's on this line. So on this line right here, I can label 1 more point. I'll label it right here. And on this line, I can label 1 more point. Label it right there. because we said we can label at least 2 points on a line. So here we go. How many points do we have now? 1, 2, 3. We have 3 points, so we have one plane that contains these lines. There's one unique plane that contains all these lines, and they would lie on that plane. Okay, that's the end.